Good morning, everybody. It's Monday morning. I got rested up really good. I feel way better today than I did yesterday. I'm having some breathing, deep breathing things going on, so I don't think I'm going to get around that today. You're going to definitely be seeing that. But anyways, I came out here this morning, and I don't have drive dogs for my lathe at all, none, zero. I can't begin to tell you how many jobs I've done over my career without lathe dogs. But the smaller diameter work pieces, you can get away with no lathe dogs. You don't need drive dogs to do small diameter work pieces between centers. Um, I know this for a fact because I've been doing it for decades. But this here, when we start getting a bigger diameter workpiece, we need to pay attention to this because the loading of the tool, the depth of cut, feed rate, RPM, all is going to load this much harder than a smaller diameter workpiece. And it'd be nice to have a 2 to 3 inch drive dog right now on this, but we don't have one. So I'm gonna cut this, and we're not doing big cuts, so I know I can get. Well, I already got a beautiful finish because I already indicated this in. This is where I'm going to go here. So I put it in the chuck. I'm only drawing on about a half an inch, and I just took a dead blow with an indicator, and I ran this at 500 RPM. And of course, being that long out of the chuck, we were getting this on the end. Over down towards the chuck seemed to be running true, but then we were getting this. So I just took a dead blow and tapped it down till I was under 5 thousandths all the way. I went in, I did my center drill hole, and I put my live center in. So we're cutting between a chuck and a live center. We're not doing a big OD reducing machine here. I'm only going to skim cut it and get it true. And then I'm going to do a light, I already did it. I already did the light facing of this, the end that's in the live center now. We're going to turn around and face the other side, and it's going to be pretty damn accurate. This is 9 inches long. We're finishing at 8.5, 8,300, 8,500. Right in there is what I need. So that's what we're going to do. And then I'm kind of past, I wrote down what I make sure I cover here. We have no workpiece support also. So some of these machining operations I'm going to be doing here today are going to be with no workpiece support when I should have workpiece support. My steady rest will not go around that diameter. It's just short of going around that diameter. So I'm not going to, I wanted to use a steady rest and hold it while I do a bore on the lathe. But how I'm going to end up doing this entire operation to get this channel done, we're not going to do a complete channel. We're only going to go in both ends a couple inches, a few inches. And how we're going to do that, we're going to do an offset bore. And that's going to require a little bit of machine in the milling machine to get our indicating holes done, so I can put it back in the lathe and indicate it in, and then offset it in the lathe and do an offset bore. So we're not going to do a channel. We're actually going to do a half moon. At the end, it'll be two diameters that meet each other right here, and this will be a half moon right here. That's just from doing an offset bore, which is real easy. But I got to do it with no work support, no workpiece support at all. Then this is going to be sensitive. We can do it. I know how to overcome it. And I don't want you guys to see this as correct machining manners, because it is not. It should not be done this way. But we're working with what we have. I have the experience behind me to do this without destroying shit. And that's what we're going to do. Anytime leverage is introduced into a machine operation, it's bad. That's tool length, part length, the milling head being way up, part sitting straight up like this, and this part's only supported down here, and there's all this is sitting out, the head's way up here, and we're going to come in. You're asking for chatter, vibration, just all the bullshit that comes along with shitty setups. So I'm going to overcome some of that today, and I might just do it and not even video it, because I don't even want you people to see me do this shit. But I have to do it, and I will do it, and we'll be successful. So anyways, let me see here. Did I hit everything? Why a broach is better, obviously, because we can get around these types of setups. Broaching is definitely is going to make a beautiful machine operation. It's going to give us a beautiful result. I'm going to get a beautiful result here because, again, I'm going to put experience into it and get past the difficulties that are going to arise here. The obstacles that are coming my way today are coming. I know this. but I also know how to overcome them. So we're going to get it done. Let me see if I hit everything. Yeah, teach correct machining manners. That's what all this is about, is making sure you guys learn correctly, to do it correctly, and don't do shit work. I've had some people say, why don't you do this? Why don't you do that? Yeah, I could do it all that ways, but it ended up being shit work at the end because you're not going to get the finishes. You're not going to get accurate cuts. The accuracy and precision in any machining operation is what we should be striving for as a machinist or a toolmaker. This is what we strive for. This is what I strive for. I'm not going to do shit work. So there's so many different ways I could do this, but they won't produce accurate results. It'll get the job done, but it won't produce accurate, beautiful results. That's what I do, nothing less. So anyways, so I went across the milling head being high, rigidity and integrity coming into play on all these. This is indicated to 0 within 5 thou right now. I went ahead and did a light cut, and it's beautiful. So we're going to do our OD, turn around, face the other side, and it's going to be ready to go in the mill. I'm considering selling this milling machine, and the reason being, I love this mill. But when I originally bought this mill, I wanted a much bigger milling machine. And they were back ordered for so long, and I had work on the table. I just couldn't do it. And this mill had everything I needed to do what I do here, but it wasn't big to where the rigidity was what I was looking for in the machine. And I have a space issue here. This is what I was able to afford to do when I wanted to put my little shop in. And space is a problem. That's why I would love to have an engine lathe and a Bridgeport. Believe me, I would. Absolutely. But I don't have the space for it. And I didn't have the money to build concrete building floors and this. I got wooden floor that I doubled the thickness on. I got block around the outside of my building to hold the weight. And this is what I was able to, capacity that I was able to deal with and still do what I wanted to do in here. And this lathe has turned out to be an incredible lathe. A 12 by 36, and I can do some incredible work with it. It's amazing. And the mill's the same way. But certain jobs would be so much better if I had much more rigidity, more capacity. Yeah. But this mill does a wonderful job. And it was small enough that and heavy enough that I was able to say, okay, I'm just going to get this. This one was available at the time. I couldn't get the one I wanted. So I bought this PM30. At the moment, it appears one of the mills that I would really, really love to have is available. So I might end up selling this milling machine, and I don't think I'm going to be able to buy the new mill until this is sold because of finances. And boy, this is going to be hard to get over on the wife because it's going to be if I sell this for what it's worth, these are back ordered right now. This is an excellent mill, and I've tuned it. I've tuned this mill. This mill is way better than one out of the box. So I'm going to probably consider selling this. I'm not sure I'm going to do it yet because I don't want any downtime, and selling a mill, not having one for days until I can get another one here, and then going through all the setup, getting a new mill set up. That could take a week and a half of me just tuning it because I'm going to do that. I'm going to take my mill apart and make it better. That's how I got this one doing so well. This mill is awesome, man. I can do some pretty good shit work on it. But still, capacity can be a problem at times. Rigidity can be a problem, and that's what I wanted to begin with. And this mill's done me justice, no question. This mill has absolutely been awesome. I can't say much about the stand it's sitting on, and the Z lead screw's got a lot of play in it, but that hasn't played any role in anything. But the lead screw on the Z, nah, I don't know how a machine can get out of a manufacturing facility with a lead screw with that much slop in it, but just the one on the Z. But we have a dro, and it's not hard to still use it even with the play in it. We just the dro's accurate, so we haven't really had any issues with that. But anyways, so I'm thinking about selling it. That's where I am. I'm gonna get busy on this so we can get it in the mill and get this video done today. I'm probably going to do a part 1 today, and I'm sure it's going to say part 1 on the thumbnail tonight. So everybody, just so you know, YouTube again, they attacked that video again last night. I just get an incredible giggle out of this. This is actually turning comical, just absolutely comical. I said something again. This is twice now, 2 nights in a row. I said something about a video that had 7,100 views, blah, 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 blah. And again, last night, they attacked the same video again. I woke up this morning and had another 500 views removed from it. Wow. Small brains, weakness. Oh my God. I can't imagine people who are so small that they need to do this to somebody to justify their feelings. Wow. Oh, wow. I just can't get over that. But anyway, this is comical, so I'm going to keep doing it because I like getting the laugh. They're not hurting me any. I'll overcome all of this one way or another. But anyways, these people exist and they're still doing it. So let's all laugh at them and let's do some good work here. So I'm going to get busy. Where's my remote? I hit everything here. Let me get busy. I'm sorry I talk too much. Love y'all, and let's get machining. Okay, I thought I'd real quickly show you how true this is spinning. That's how good we have it. You can see if you look right here, kind of looking like it's at a horizon, you can see it is, oh shit, hold on, I just fucked up. There we go. I'm not editing that out. But there you go. It is spinning very true. So we're just going to do a skim cut. I've already done it. Look at the accuracy of it. Beautiful. You can see it. So there you go. I'm going to get busy here, but I wanted to show you how true I have it in here from the get-go. And this is going to allow me to do this very first cuts the way I need to do them. So let me get busy again. So we just finished doing the OD cut. As you can see, it's pretty. It's definitely pretty. And beautiful finish. And it's not bad. I'm really happy with it. So at this point, we're going to undo the live center, push the tailstock back. I'm going to turn this around, and I'm going to face off quite a bit. And it's going to be way out here, me facing it, and putting a lot of load out here on the end of this. So I don't think I'm going to video that because I don't want you guys to see me doing this the way it should not be done without support. But then again, we'll see how I feel about this. But either way, this is what we're going to do, and this will help shorten these videos as well. You can see I got that done. You can't really see the face in here. Hold on, let me see if I can get this to... Okay, so there's your face. There's the part. And we're now going to turn around, bring it into length, and then we're going to move it over to the mill. So I will, I'll go ahead and turn this around. Now I think I'm going to face it with no video because you can see what I'm doing. It's just facing operation. But again, it's going to be way out of the part. If I have some obstacles I got to overcome, I'll overcome them and we'll get this done. And I'll be back at you for the next setup. So this is what I decided to do to give myself a little bit of support. And then I'll have a lot less machine off of it at the end. So I'm using the live center. I'm facing right up to the center. You can see that little step forming right there. So this is a 30 thou cut right here. So let's do it. And this is what I'm going to do until I bring it into length. So here we go. We're working with what we have. You can look at that cut. That's feeds and speeds right there that are playing a role in why I'm getting such a shitty chip flow. So I'm just showing you how big of a cut I'm doing. It's quite large, but I'm feeding it by hand and I'm taking off quite a bit of material at the time. But now I'm doing OD cuts. So where my live center is placed, I don't want that wall to get so thin that the live center no longer gives it any support. But I'm doing every bit of a 200,000 cut right here, as you can see. And I'm just going to do this until I get all the way down to that wall at the live center. And then we're going to take that out and face that little piece off real fast. Get a nice pre-finish on here. We finish this cut. And this is all feeds and speeds, depth of cut. But I got to do what I got to do, so I'm doing it. And we're going to come back out. And we're going to do another cut. But I wanted you to see that. So I'm going to finish this up and then bring you back. Okay, so here we go. You can see what I've done here. So basically, I faced it down until this wall right here with the live center got thin. So at that point, I could not side load the part anymore with the cutter facing. So I started cutting OD back until I met the two right there. So at this point, I got a little teeny step right here. It's just below or past the finish length. So I didn't overcut it. And at this point, I'm going to take this center out, and it's going to be incredibly easy with this length outside of this this chuck right here. It's going to be incredibly easy to face that off and get a nice, pretty 90-degree face to the OD right here. So that's what we're going to do. I just wanted to show you how I did this, and I did it by overcoming some obstacles that present themselves in jobs like this. So we used the center for support, and then we cut it in a manner in which it didn't weaken this wall right here and throw this out of true. So she's true as can be. I'm going to turn it on and spin her. She's spinning at 840, so let's watch how true she is. There you go. Pretty damn true. And there's our face. So I'm going to get this done, pull it out of the lathe, and I'll show it to you before we put it in the mill. Now I went ahead and decided to show you. So what we're doing here, now we have the supports gone. I'm just going to cut the OD all the way to that face. And this way I don't side load the part at all. I cut directly in the center of the part towards the chuck, not allowing this part to continue to spin true, and get this taken care of with what we have here. So let's do this. I'll show you one cut real quick, and we can take a decent cut. That's a little one. We'll just do a little one for now, but as you can see, this is all I'm going to do. Is I'm going to reduce this diameter until I get to the center of the part, and then all I got to do is a couple light facing cuts across the face, but they won't load the part so much it'll throw it out of true, because those facing cuts are going to be so small. So this is how I'm doing this, and I'm going to go ahead and actually complete this now, and I'll bring you back after I'm done. Here we go. We're going to do a light face, let you see this, and we're going to bring this into length. I only got to take maybe 25 thou off of it, and we'll be in the length. And you can see by taking a light face cut, it's not throwing it out of true. So, okay, I'm actually going to hand feed this and get it done. So you have seen the entire process for how I did this. So let me turn this off and we'll bring it back in a sec. Okay, I thought I'd show you the indication on this. Let me show you the whole part. There it is. I just took all that out, did my face. But what I want to show you is how true this part still is. And it's accurate enough where this has no bearing on my doing shit work or me doing excellent work, because this is excellent work. I'm within 2/1000ths of an inch right here. Let's get in here so you can see this. Okay. Now let me roll this with the other hand while I'm holding this. We're under 2/1000ths of an inch. You can see it. Just under 2/1000ths. Let me get you straighter on this. Okay. So it's rated 62, 63, and it doesn't even hit 64. Just below. It's actually 1.5 thou in. That's how true I was able to keep this part sitting that far out of the lathe, doing it the way I did it. So now I can do some real light face cuts, and I know I'm within 1.5 thousandths to a 90-degree right here. And this is going to play a big role in the operations that are coming, and keeping this part accurate, true, and doing fantastic work. So let me grab my remote. I'm going to shut this off. We're taking this out. And I haven't had anything to eat yet, so I'm going to go in and grab me some French toast. And I'll be back out here and we'll get back on this. Okay, we got it out of the lathe. Beautiful, beautiful result. Very, very beautiful result. So basically, I have me a very small little hole right there. It's going to allow me to indicate in. And I I was going to make it bigger, but I decided to keep it small. That way I can get a super accurate indication. The smaller the hole, the more movement you'll get over a smaller distance there with your indicator. And we're going to do it right. There you go. That's done all the wrong ways and accomplished. So there we go. There's the beginning of our handguard. So we got our OD where we want it, right where we want it. Now remember, I'm machining the picatinny into this. And that's why we're starting with this. If I was in a job shop, I'll guarantee you I'd have started with a solid round. They wouldn't have had tube in inventory. I guarantee they wouldn't have had tube. They would have handed me a solid round, or I would have cut it. They would have. That's all I would have had to choose from. They would have handed me a blueprint, and I'd went over and pulled material and started off in a saw by cutting a raw piece to the length I need to start the machine job. So here we are. And I didn't go in and eat my French toast yet. I went ahead and finished this and got it out of the lathe for y'all. Now, you'll notice, if you took note, I didn't put brass around it to protect it from the jaws. And the reason being, and I got a little bit of a mark, little jaw mark right there. I think you can see it. Yeah, right there. You can see it. But it's not even something you can feel with your finger. It was I had jawed on it with the right amount of pressure. But we're milling all this off. So this didn't matter at all. So I didn't really give a shit about protecting the surface from marring. I knew I was going to mill all this off, and that was the deal. So here we go. I'm going to go get my French toast now, and we'll bring it back. I'm going to get this in the mill, and we're going to try to get this mostly done today. But either way, it'll be a part one. We'll get a lot done on this today. It's only noon right now. I haven't had breakfast. I came out here. I left my coffee in the house. This is me. This is the person you're going to get to learn, get to know me. So I came out here. I'd warmed the stuff up. I went in to get I forget what I went in to grab. And I came back out and I left my coffee in there hot. I just poured it. And I was going to come out here and turn the lathe on, just let the lathe run at 100 RPM for a little while and go back in the house, just let it run for a while by itself. I don't have any issues with that. I know everything's disengaged. I move everything out of the way, and it's just sitting there spinning at 100 RPM. And that's just to get a little heat started in it in these cold mornings. And it wasn't hateful cold in here this morning. It was 51 degrees. I usually keep my temperature to where it's 50 degrees in here when I come in. So I came out, and before I know it, here I'm showing you this, and my coffee's still sitting there. I never went back in the house to do anything. I came out and went straight to work and stayed on it until it was done. But I do that. That's me. You know, I get busy and I stay at it, and that's just who I've always been. I don't know if it's a fault or it's a good thing, but my coffee's ice cold and it's now lunchtime. So I'm going in and get my French toast for lunch, and then I'm going to come back out and put this in the mill, and we're going to get this ready to do an offset bore. And I'll see y'all shortly. I decided to go ahead and do the main bore now in the lathe before I put it in the mill. And I just did a time lapse. I just came in from eating and I just did a time lapse on it up to this point. So now I'm getting ready to put the boring bar in. I just ran the last silver and Deming bit I ran in was 1 inch. We're going to 1375. So that's what I'm going to do at this point. So we have plunged in 5 inches. This is 8.3 inches long. So we are now have a drill depth of 5 inches. So this is going to be good. When I turn this around, indicated in, I'm only going to have to do a little over 3 inches to get these bores to blend together, to come together. But we're doing it again with what we have. So basically what I did, I stepped up. I started with a small drill bit, and I step up in size. So I'm taking less wall out with each drill bit. And when you take less wall out with the drill bit in this manner, you get a much truer hole. Much more accurate hole is able to be done. And of course, this is a rough cut. And when we run the boring bar in, we'll finish it with a boring bar. So I'm going to go ahead and put the boring bar in. We're going to do this diameter to 1.35 or 1.375. Then when we put it in the mill, we'll indicate this bore end. Then we're going to offset and punch our hole for where this excuse me, I can't, sometimes I can't come up with words that are right on the tip of my tongue, but the channel, the gas tube channel. So that's how we're going to do this. And I was thinking of boring it in the lathe, offsetting it, but I think I'm not going to have any problem just using a boring bar, or maybe just a large end mill, a 375 end mill. I have some extra long 1/4 inch end mills that will actually do it. And I can offset, get my position, my location of where the gas tube is going to travel. And then at that point, sitting even this length, sitting straight up in the mill with that milling head straight, as high as it is, we're going to be plunging straight down. So this won't create near the trouble when it comes to vibration and chatter and all that, because we're drilling straight down. Or we'll use an end mill and center cut straight down. So we're not to that point yet. So I'm going to do my bore. We'll get 375. We're going to turn around, indicate it in, and do another bore 375 and blend them in the middle. Now, this isn't something you're going to be able to readily see with your eye. So I'm not going to look for doing an absolute pristine job of getting these two bores to blend perfectly together. I'm not going to give a shit if there's a couple thousand step where these two bores meet each other on the inside. So let me get busy doing this. You're going to see the boring operation now. You're going to see me turn it around. We're going to do the same thing. We're going to step up with drill bits, and then we're going to finish boring the 1.375 and bring these two bores together. I'm going to do all that on time lapse, and I'm not going to talk again until that's done. So I'll see you when we're finished with this. Okay, I just finished hitting the bore, and with this workpiece being a little longer than here, let me try to get me in here a little bit. So with this workpiece, mask is on, lots of debris flying around on this job. Okay, with this being a little longer, I've gotten a little chatter right here, and this is one of these obstacles that presents itself when you do jobs in this fashion, which I talked about earlier. Chatter, vibration is not hateful at all, but we did get some, and I got this board done. Remember the barrel nut? There it is. Now, and we want a nice pristine fit, not real sloppy. And there it is. It's a little looser than I wanted it because I'm making sure it clears the gas block. So, but it's plenty. It's plenty. It's only about, I mean, I can barely move it back and forth. I'm going to say it's about 4 thousandths, 3 to 4 thousandths clearance. Okay. So at this point, what we're going to do, I'm going to turn this around and do the same operation on the other side and blend these bores in the middle. And I'm not going to worry about getting this absolutely perfect on the inside because we're not going to be able to see it. And the OD's already done. And in fact, if we're going to mill everything off of it, we don't have any worry about blending on this one. So let me get this turned around, indicated in. I wish I didn't get any chatter at all, but we did. But that's just not that bad. That could have been so much worse. So I'm going to get this turned around, indicated in, and bored. And I think we did all this on time lapse so you saw it. So I'm not going to film the other side because it's basically exactly what you just saw. It is exactly what you just saw. So we're not going to do it. I'm going to just get the job done, get it out, and we can go put it in the mill and do our offset hole for our gas tube. Okay, I'm going to turn this off and get busy. Okay, I went ahead and punched that. There was only 3.5 inches to go, and I did it so fast. And I've already got the boring bar going in. I'm already sitting at 1/200. I got 175 to go to this bore. So I'm going to go ahead and time lapse it because it's not going to take very long at all. So I'm pretty much done this bore. 175 to go, and we're done this bore. And we'll put it in the mill and do our offset. So I'm going to line this back up and do this in time lapse. Okay, we got it done. So let's take the barrel nut again on this side. So this is the other side, barrel nut. I'm going to take this out here in a second and put it up on the workbench. We need to go over a few things. There we go. I wish this thing worked a little bit better. There we go. It doesn't like the... You'll notice earlier in the video, you might catch it. I think it's in time lapse. I knocked the camera off the holder up here, the mount, and it fell down into the lathe. But anyways, see what we got. There you go. And you can see it. I mean, you can probably see it right there. This is a good fit. Excellent fit. So, we have the board done. Let me get some debris out of there. Nice thing about once it's a through hole, I can knock all the debris out like that while I'm boring. Chip evacuation is a problem on this too. So there's been a few obstacles we've had to overcome here. And we did it. It's done. So, let's take it out. And you can... I'll show you how pretty the board is. I mean, it's way better than you would think. But we know why. But the average, if the average person that has a lathe that not really has much machining experience, they would never be able to accomplish this. They wouldn't know what to do in order to get around the obstacles that come up in a job like this. But since I already knew the obstacles and I've been overcoming them for 30 years, it was just another day in the shop. So, there's your board. Okay? Let's see how well it met. Holy shit, we did a good job. Really good job. I'd say it's 2,000. I don't know if you can see it in there. It's about 2,000 difference between the two boards, which is not a big deal at all. So I'm going to put this over here and let me shut this off. We'll talk. So what I'm going to do now, we're going to talk about putting it in the mill and doing an offset right here for the gas tube. Out of the lathe. I think at some point I'll get some better lighting here just so I can show you things better. But there's our bore. Not bad at all. That's crazy. I pulled that off. Look at that. It's not hateful. And in there is somewhere, I don't know if you can see it, it's about 2,000 steps. Barely noticeable. But we got that done. So at this point, here's where we're going. We're going to set this on the mill, straight up and down. I took the head all the way up earlier. The head's up way higher than it needs to be. And I'm going to come in with probably, I have one extra long, I might center drill it first and then plunge a small drill bit down through. I got to go 3.5 inches, 4 inches right there. and it'll clear. I'm going to show you something. I have a barrel right here next to me. I'm not going to show everything because we know how these small-brained idiots are on YouTube. No, they'll find this to be offensive. They'll go home and cry to their mama. So anyway, this spot right here is what I'm trying to clear. That bend. Okay. So here we got the bore will clear this, and I got to go in and cut to do this. But what I'm holding here is an upper with a barrel on it, and that's it. And it's only for this purpose. But we don't want to make them take 6,000 views tonight. That just kills me. I mentioned that video again in that last night in the video. I mentioned the 7,100 count video, and they attacked it again. Woke up this morning, it was another 500 views taken all over. That just kills me. That is so comical. But anyways, small brains. That's a fact. Okay, so here we are. So first thing I'm going to do, and I put in the mill, is I'm going to cut the 4 flats on it, turn it, cut, turn it, cut 90 from each other. And what that's going to allow me to do is put it right in the vise, right up against the jaw, and just come straight off the center of this up to where I want my offset hole, and it'll be real easy. And it'll be damn perfectly square to the picatinny rail we're going to put in, because we're going to do the flats first. I could get away with doing 2 flats, and I might just do that, but we'll see how it goes. But that's where we're at, and this isn't going to take very long. The mill's a mess from the other day, so I got to clean that up first, and we'll get this in, and we'll get this done. I'm not sure how much I'm going to get done here today on this, but this will be part 1. We're going to get pretty far on it, and I'm going to try to get this uploaded tonight. Give them something else to cry about. Okay, let me get busy here, and I'll be with you in a minute. Okay, I'm going to move this out of the way real quick while I bring the head up. So we cut our 4 flats. I went ahead and did 4. Now this makes it really easy to take that part, put it in the vise, and it'll center itself, or it'll square itself up to where I come off the center to cut the offset hole. It'll be dead in line with those flats, because we're going to put it up against the hard jaw of the vise. So let me get this. Let me so the thumb switch is backwards in one direction and correct in another. So okay, so I'm going to raise the head up. We're going to rotate this. I already loosened it up. Here are flats are cut. Okay, so 1, 2, 3, 4. I didn't want to cut them very deep yet, because I got to get this offset. Then I got to measure for my clamp and the picatinny. So that we don't want to cut too deep on these flats yet. And I went 20,000 in on each one, so they're identical. So I got a little burr right there that I want to knock off before I put it in the mill. Let me knock that off real quick. Where's my favorite file? Okay. Because that'll make it sit, not sit flat in the mill on the vise. It's not a big burr, just a little teeny one. So I'm going to shut the camera off, raise the milling head. I'm going to do a time lapse just punching this channel, and that's going to be what happens until the channel's done. So let me get to this, turning this off. Next thing you're going to see is a time lapse of me doing a half moon. It's going to be actually 2 diameters that intersect right here. And basically I'm putting a half moon in it. It's not going to be a nice square channel through there. It's going to be a half moon that allows the clearance, and it will clear. Work perfect. I'll be right back with you. Okay, I'm going to bring you in. So this is what I say is a no-no right here. But I have an extremely firm grip on it. and how I'm going to go about punching that hole straight down. Will not put any side load, right or left, front or forward, on the part. So we got this over to the center of our gas port hole. I'm just going to punch a little center drill mark. Then I'm going to run a small drill bit down to it just to give my end mill some relief. So the end mill is not cutting a full cut. It's just going to take the wall out when I finish it up. So let me get started on this, and we'll get this offset cut. And let me adjust this up so you can watch it. But we'll do it on time lapse. So I want this video to go quick. But here we are. We're ready to do it. I'm going to plunge this drill bit end mill. Let me. I just finished cutting the gas tube relief, the offset. I did everything wrong, way you should not freaking do it. All right, so but the point was getting it done in the shop with what I have. Right, that's the deal. We're successful. No broken tools. Everything went smooth glass. I extended a 1/4 inch long reach end mill out to 3.5 inches and side cut with it inside. Works fine. It was making quite a bit of noise, but it worked great. So let's pour this out while you're looking. And I'll guarantee it slides right across that gas tube. There you go, my friends. Done. Just deep enough. That gas tube will slide right up in there. Excellent result. Let me clean it up. I think I'm going to call it a night. I'm going to hit it with a lot of air here. A lot of debris in there. Okay, I'm going to shut this off. I'm going to take a rag. Yeah, we don't have a lot of light. Might be able to see it this way. There you go. That's 4 inches deep. Wow, that's straight. That's incredible. That's incredible. Now we got it done. That's all that matters. Okay, I'm going to turn this off, run a rag down there, clean it up a little bit. Hello. It's Tuesday. So I slept good Sunday night. I woke up yesterday morning, felt pretty darn good. So I came out here to get back on this handguard. The last clip I shot, I went back and looked, was in the mill and me patting myself from the back saying, oh yeah, I got the relief cut. Well, I should have kept my mouth shut. That's basically what this boils down to. All the challenges I knew were going to present themselves, presented themselves. Everyone came at exactly when I thought it would, and they did. Well, I got past, I kept getting past these little challenges all the way up to the mill machine. I managed to get the smaller spot of this slot cut, or it's actually a relief for the gas tube and the gas block. And that was in this last clip, which you just saw before you're seeing me now. Well, I ended up shortening this. It's now carbine length, and it should be anyways because I want to do this with a 4150 gas block. I want to make this coming week for it, and it needs to be right up to the gas block. So here's an upper. We now are successful. Yesterday, I can't say success was even. By the time I got out of here last night, went in, I'm surprised I have any hair left. That's how crazy it became. So here we are. It fits, no problem. But when I went inside last night, it wasn't going on, and I had some problems. And they were absolutely exactly what I thought was going to occur, but I was certain I could overcome them. So everything I did to overcome them didn't work at all. This is one of them things. Do not try this at home because everything I do in this video is being done the wrong way, but we got it done. So what happened is I was literally right down in the middle here. I had to cut part of the channel, flip it over, same thing. I had to cut a channel on the other side and get them to meet cleanly in the middle. So I knew I was going to have to extend end mills, and I talk about this a little bit before, before now in this video. But anytime you introduce leverage into a machining, into machining, it's a bad thing. It's always a bad thing. It never turns out good. And end mill chatter and length of an end mill is how it goes, and which I knew was coming. Well, as I got further and further down in here, remember this was 8-inch 300 long. I was literally within a half an inch of workable to total disaster. I was doing just fine until I got within a half an inch of the meeting in the middle. And the chatter became, I couldn't overcome it. I absolutely could not do it. I did everything I knew, and I couldn't do it. And I didn't want to destroy this, and that's what was coming. If I'd have kept at it yesterday, I'd have destroyed this handguard for sure. Anyways, I'm way down in there and I'm pulling it off. I'm like, man, I'm almost there. I'm almost there. Half an inch was all it was between it was working good, I was overcoming it to couldn't overcome it. The only way to get this done was to shorten it. So I ended up coming in here this morning, throwing it in the lathe, indicating it in. I cooked an inch off the front. I made it carbine. It now fits the carbine perfectly. Okay, and we did really want to do this because I wanted to put a picatinny gas block on the upper with a handguard. So it now comes up to the gas block like a normal carbine would, and we'll get a picatinny gas block put on it. But anyways, I came in this morning and I went in the house last night. I'm surprised I have any hair left because I was just frustrated. I could not get past this chatter, and I was within a half inch of finishing this. My batteries. Hold on, let me plug this in real quick. I'm gonna move this slightly because the battery thing just came on. I hope that's not in the video. Where is it? Right there. Okay, there we are. So I came in this morning. I shortened it, put it in the mill. Success. That half an inch was exactly what the problem was. A half an inch, literally from it working. Didn't work great, but it worked. So just a little bit further plunging down, total fucking vibration and chatter, and I couldn't get past it. There was just no way. So I came in this morning after thinking about it last night, and I got it done. There's your channel. Little shiny up in there. See the little shiny spot? That's from the file. I ran a round file down through to clean the burrs up. There you go. Channel's done, and it's not bad at all. It's amazing what a half an inch did to me yesterday. So again, do not try this at home. Everything you see in this video should not be tried at home, and it's all wrong. I did everything wrong, but we got the job done. So at this point, I need to put it back in the mill. I spent all morning in here getting them cut, getting them to meet in the middle pretty, getting the burrs out, and here I am. I'm finally where I should have been yesterday before I went in the house. This all should have been done. but that wasn't how it went. So at this point, I'm going to end up doing, this is going to be part 1. I'm putting this in the mill as soon as I shut this off. I'm going to bring this over, and all I'm going to do is record me bringing these flats in the dimension. These two have a certain width. I think I'm going to go a little bit bigger than one of these handguards. Not a whole lot, just a little wider. Then I got to put the clamp in. And I think part 2 is going to be nothing but putting the picatinny rail in and doing my final operations to it. So as of tonight, you should be seeing a video with the flats cut, and I might go as far as putting bringing the rail into the width dimension. So that way, as I bring the picatinny cutter in, I can put a little dicom on the side of it, and I can see when that 90-degree inclusive angle in the picatinny cutter is starting to touch that dicom when the points getting close to 832, the dimension. So I'm going to put it in here. I'm going to get busy on this. But we had a really frustrating day yesterday, and everything I said would present itself and become an obstacle became an obstacle, and literally to the point I couldn't overcome it. And I thought for sure I would be able to. So anyways, let me get busy here, and I'll bring you back. I will get some time-lapse video of me cutting these flats on here, and we'll get this video done. Okay, I got to take 387 thousandths off each side. So that's what we're going to do. We're going to do this in time-lapse, get these flats cut real quick. This video is going much longer than I wanted it to. So let me get going here, and I'll talk to you when we're done. I really hope y'all enjoyed part 1 here. I changed a lot of things up throughout this video, but here we go. This is where we're at right now with the handguard. It's out of the mill. All the flats are done. We're ready to. We still have to do the picatinny, finish the clamp, and take some more material off to lighten it up considerably. I hope you all enjoyed your video. Please like, share, and subscribe. I love y'all, and I'll start part 2 in the morning. Take care.